we are going to study a very important chapter of class 12 physics, that is ray optics and optical instruments. So let's start. Everyone must have studied light chapter in class 10th. It is very similar to that. So first we'll see what is light. Light, it is a form of energy. Light is a form of energy that creates sensation of vision in our eyes. Means when light comes from a source and falls into an object. For example, this board is an object. When light comes from a source, falls on this board and reflects back to our eyes, then only we are capable to see this board. Unless otherwise we can't see this board. So we can say light is a form of energy which creates sensation of vision in our sight, or which it makes things visible to us. Next is rays of light. Ray of light. A straight line drawn in the direction of propagation of light is called ray of light. Let's see. For example, this is a torch. In this direction, the direction of light flow is this. So the straight line drawn, this is, let's say this is a straight line drawn in the direction of light. So the straight line drawn in the direction of propagation of light is called ray of light. Next is characteristics of light. Light has, we can say, there are three characteristics of light, and out of which a form of wave as well as it travels in a straight path. First characteristic is light wave electromagnetic waves. Let's say that this is a torch, this is the flow of light. How light flows? Light flows in a form of wave. It flows like this, in a form of wave. This wave form of light, it is called electromagnetic wave or electromagnetic nature of light. Next is transverse nature. Next is transverse nature. Transverse nature means light always. So let's say this is a single point. When light rays comes from a single point and diverge in different directions or deviate in different directions, this is called divergent beam of light, and this is just opposite to convergent beam of light. So we have studied three types of beam of light. That first is parallel beam of light, next is convergent beam of light, and last one is divergent beam of light. Next difference between ray and beam. There are certain difference between a ray and beam. On basis of some features. First feature is definition. Ray means single path. And beam means a bundle of rays, or we can say many rays. This is a short difference between representation. Next feature is representation. This is arrowed line. This is bundle of lines. Last is types. There is no such types of rays of light, but so we can write here none. For beam of light there are three types of light. Three types we will not say, we will write the three types: parallel, convergent and divergent. So this is the basic difference between. This can come in exams. Next is, what is reflection? From here main topic starts. What is reflection? The phenomenon of bouncing back of light after striking a reflecting surface is called reflection. And light after reflection returns back in the same medium. Let's see. Let's say this is a reflecting surface. This side is a reflecting surface. This is the reflecting surface, and this is air medium. Here is a torch. Light ray came from the torch, meet at the center, and reflect back in the same medium. This is called reflection of light. Again, I am saying the definition: the phenomenon of bouncing back of light in the same medium after striking a reflecting surface is called reflection of light. Next is types of reflection. Types of reflection. There are two types of reflection: regular reflection or specular reflection. So what is regular or specular reflection? When rays of light comes from a source and touch a polished surface, then the rays reflect in a proper manner or deviate in a proper manner. That is called regular or specular reflection. Means this is a mirror. One side is properly polished, means this reflecting part is properly polished or plain surface, then light will fall and reflect in a particular manner. So this is called regular or specular reflection. It forms clear image. Second type is irregular or diffuse reflection. It is just opposite to specular reflection. When light rays comes from a source and touch a irregular or unpolished surface, that is called that time light deflects in improper way. Let's see the diagram. Let's say this is the reflecting surface whose surface is little rough one. Then when light ray will fall, it will not reflect in a proper manner. It will deflect this way or this way or this way. This is called diffuse reflection. It is just opposite to specular reflection, and it forms irregular image or no clear image, you can write. Now we'll see what is incident ray. These are the terms related to reflection. Incident ray. The ray of light that comes from the source is called incident ray. Means, let's say this is the torch. The ray of light that comes from the torch is called incident ray. Next is reflected ray. Reflected ray, when light falls on a reflecting surface and reflect in a particular manner, that is called reflected ray. For example, this is a plain or polished surface. This is the incident ray. Light coming from a source. Let's see, this is sun, which is a source of light. When light comes from sun and touches the reflecting surface, it reflects in a particular manner. This ray of light is called reflected ray. And the third one is normal. It is a perpendicular line drawn. It is the perpendicular line drawn parallel to the reflecting surface. It is perpendicular to the reflecting surface. This line is called normal. The next is laws of reflection. There are two laws of reflection. First law is angle of incidence is equal to angle of reflection. Hence, that is angle I equal to angle R. Angle of incidence equal to angle of reflection. Let's say this is a polished surface. This is the incident ray falling on the reflecting surface, reflecting back in a proper manner. This is the normal, which is perpendicular to the reflecting surface. Here we will say I, R. The angle of incidence. What is angle of incidence? First we will see the angle between incident ray and normal. The angle between incident ray and normal, that is called angle of incidence or angle I. And this, what is angle of reflection? The angle drawn between reflected ray and normal is called angle of reflection, angle R. And angle I equal to angle R. This is first law of reflection. Second law, incident ray normal, reflected ray lie on same plane. This is the reflecting surface. Incident ray, normal, reflected ray. This is the incident ray and this is the point of incidence. Incident ray, normal and reflected ray all lie in the same plane. On this single plane, these three lines lie. So this is the second law of reflection, that is incident ray, reflected ray and normal at the point of incidence, they lie on the same plane. Next. Next is mirror. What is mirror? A highly polished and highly reflecting surface whose one side is silver polished, that is called a mirror. Let's say this is a mirror. This part is the reflecting part, which is highly polished and highly reflecting, and this part is the silver polished part. And in all mirror, the opposite side of this polished part or reflecting part is silver polished. You can say highly polished reflecting surface. It is called mirror. And then there are types of mirror. There are basically two types of mirror. First is plane mirror. Second one is spherical mirror. Spherical mirror. Plane mirror. It is a flat surface or a highly polished or reflecting surface which is flat, that is called plane mirror. This is the proper example of plane mirror, which is flat. The mirror we normally use at our homes is plane mirror. And next one is spherical mirror. It is also a type of mirror whose reflecting surface is highly polished and it is a part of a sphere. That is why it is called spherical mirror. Means this is a sphere whose either this part or this part is a reflecting side. So this is called spherical mirror. There are two types of spherical mirror. We will study. Types of spherical mirror. First is concave mirror. Concave mirror is the mirror whose reflecting surface is inward. This is the example of concave mirror, whose this part means this inward curved part is the reflecting surface and this outside is silver polished. So this is the concave mirror, whose inside part is a reflecting surface and outside is silver polished. So we can say what is concave mirror? The mirror whose inward surface is highly polished or a reflecting surface. There are some characteristics. Inward curved surface, produces real and virtual image, real or virtual image. There are cases there are some certain cases in which it produces real or it produces virtual image. We'll go to that. And applications, we can say it is used in torches or telescopes. And dentist mirror is a good example of concave mirror, or shaving mirror is also a good example of concave mirror. Next, the next type of spherical mirror is convex mirror. This is a type of spherical mirror whose outward surface is highly polished or reflecting surface. It is just opposite to convex mirror. This outer part is the reflecting surface and this inner part is the silver polished part. So we can say convex mirror is just opposite to concave mirror. It has also some characteristics. Outward curved surface, produces virtual and erect. Concave mirror can produce either real or virtual image, but convex mirror only produces virtual image. An example, you can say a rear view mirror of vehicles. Yes, that is the best example. Street lights, these are the good examples of convex mirror. Then we will difference between real, virtual and plane mirror, concave mirror and convex mirror. Oh, sorry. Type. Image nature. Size, use. First is plane mirror. Plane mirror, the nature of image is virtual and erect. Size is same. As you have seen mirrors in our homes that are plane mirror, the size remains same. Then next is used as mirrors. Simple plane mirrors which are used at our houses. Next is concave mirror, real or virtual. Size varies. Sometimes size increases, sometimes size decreases. Used as torches, saving mirror, etc. Next is convex, produces only virtual and erect. Size diminished. Diminished means very small. Used in rear view mirror of vehicles. So we have distinguishes the types of mirror in categories of image nature, size and uses. Next. Then image formation in spherical mirrors. First is concave mirror. First we will draw a diagram of concave mirror. The straight line that passes through the concave mirror, this is called principal axis, and the center of the mirror is called pole. And the radius of the sphere is called the radius of curvature, and the distance, half distance between center of curvature and the pole is called focal length. So is called focus, and the distance between focus and pole is called focal length. So case 1, object is at infinity. Let's say this is center of curvature, this is focus, Let's say this is infinity. A object is standing here. When light falls on it, what happens? Where the image forms, we'll see. First we'll see what happens when light falls parallelly on the mirror or falls through the focus. If ray of light falls parallelly to the mirror, concave mirror, then it travels to the focus. If the ray of light falls through the focus and touches the mirror, then it travels parallel to the principal axis. And if the ray of light travels through the center of curvature, then it reflects back in the same direction. So these are the three conditions of reflection of light in concave mirror. Again I am drawing the diagram for the image formation. First, if case 1, if an object is an infinity, then the image will form at F, means at focus. First ray of light goes parallel to the principal axis, falls to the focus. Another ray of light goes to the focus and returns back. So here the image formation occurs. Where the both light rays meet, there only the image forms, that is at focus. So this is the first case. Second is, if a object is beyond C, then the image formation will be between F and C. Case 2. If a object, means this is C, this is F. If a object is beyond C, means here, then where will the image form? The image will be formed between focus and between focus and center of curvature, and the image is real and inverted. In these cases, in the first case also, when object was at infinity, then also the image was inverted, real and inverted, and the size was highly diminished, means very small. And in this case also it is diminished, means in this case also the image is smaller than the size of the object. So if the object is standing beyond C, means beyond center of curvature, then the image formation will be between center of curvature and focus, and the nature will be diminished. Next is case 3. Object is at C. Object is at C, then the image formed, that is real and inverted, and the image is also formed at C, means it will form at same position but is real and inverted. Size remains same, means if image of height image, means height of the object is 5 centimeter, then height of the object will also 5 centimeter. Here HO, that is height of the object, equal to height of the image, that is HI. And distance also remains same, means image distance, that is V, equal to object distance, that is U. Case 4. Between C and F. This is center of curvature and this is focus. When image is standing between center of curvature and focus, then here also image will formed is real and inverted, and the image will form beyond C, means here, and it is enlarged, means if the height of the image object is 5 centimeter, then the height of the image will be more than 5 centimeter. So this is the condition for object beyond object between center of curvature and focus. Case 5. At F, when object is standing at focus, then here then the image will be real and inverted. The image will be real and inverted, but in the position of the image is at infinity, means this is the object, and the image will be formed here, which is at infinity and real and inverted. Here also the characteristic is highly enlarged, means much greater than the size of the object. The last case of concave mirror, case 6. This is a special case. Here the object is between focal length and pole, then the image will formed enlarged, means it is also greater than the height of the object, but the image formed will be virtual and erect. This is only condition in the concave mirror, which is between focal length and focus and principal pole, where image formed is virtual and erect. Otherwise, at all conditions, the image formed in concave mirror is real and inverted. The image formed will be the image that is formed in this case is virtual and erect and enlarged, larger than the size of the object, means HI greater than HO. Next, convex mirror. For convex mirror, there is two conditions only. This is the silver polished part, this is the reflecting part, pole, center of curvature, focus. The cases of reflection in convex mirror is when light falls parallel to the principal axis, then it appears to pass through focus. It appears to pass through focus. When light appears to fall at focus, then it reflects in a parallel way, parallel to principal axis. So there are two cases of image formation in convex mirror. First is at infinity. When object is at infinity, the image will be formed at F. Light falls, reflect back, the image will be formed here, and the image is virtual and erect and diminished, means smaller than the size of the object. In convex mirror, in both the cases, the image formation is virtual and erect and diminished. This is the first case. when the object was at infinity. And the second case is in any distance except infinity, beyond our eyesight, within the limit of our eyesight, anywhere we put an object, the image will be formed between focal length and pole. The image will be formed here. It will be always smaller than the size of the object, means HO is greater than HI. Now these are the two cases of convex mirror. Next, sign conventions. First we'll see about a concave mirror. This is pole. The straight line is the principal axis. This is focus. This is center of curvature. This is focus. For concave mirror, anything that lies left to the pole is negative. That is sign. This is the sign convention. This topic is sign convention. Anything that lies left to the pole is negative and right to the pole is positive. And anything that lies above the principal axis, that is positive, and anything that lies below the principal axis, that is negative. And for concave mirror, center of curvature is always negative. Focal length is always negative. Means radius of curvature and focal length for a concave mirror is always negative. And object distance for a concave mirror is always negative. Image distance in a concave mirror is also negative, but except one case, when the image is formed between focal length and pole, that time the image distance becomes positive. Otherwise, at all conditions, the image distance and object distance both are negative. So this is sign convention for concave mirror. Next, for convex mirror. Here also same, anything that lies right to the pole is positive, left to the pole is negative, above the principal axis is positive, below the principal axis is negative. And here the focal length and radius of curvature for a convex mirror is always positive, and object distance is always negative for concave and convex both. And image distance for convex mirror is always positive. Next is mirror formula. There is a formula for calculating either focal length, or we can calculate the image distance or object distance using that. That is mirror formula. That is 1 by f equal to 1 by v plus 1 by u, where f denotes focal length. V is the image distance. U is the object distance. This is the mirror formula. Next is magnification. For magnification, there is a formula which we used to see how the image is enlarged or diminished. The formula for magnification is m equal to minus v by u, or this is equal to hi by ho. Hi is the height of the image and ho is the object height. Hi is image height and ho is object height. This is the magnification formula. And another thing, If mod of m is greater than 1, then image formed is enlarged. Means height of the image is more than the height of the object. If mod of m is less than 1, then the image formed is diminished. Means height of the image is smaller than the height of the object. Next, this is all for today. Now we'll do some numericals based on it. First question. It is given that object distance is minus 20 centimeter. Focal length is minus 10 centimeter. It is given to find V, means image distance, as well as m, that is magnification. For V there is we can put mirror formula, and for m we can put magnification formula. First we will find V. According to formula, 1 by f equal to 1 by v plus 1 by u. 1 by f means minus 1 by 10 equal to 1 by v minus 1 by 20. 1 by v equal to minus 1 by 10 plus 1 by 20. Implies that 1 by v equal to LCM is 20 minus 2 plus 1. 1 by v equal to minus 1 by 20. Implies that v equal to minus 20. So here the image formed image distance is minus 20 centimeter. Next we have to find m. M equal to hi by ho, but here image height of the image and height of the object is not given, so we can put another formula, that is minus v by u. Minus v by u. V is minus 20, u is also minus 20. This is minus of 1, it is minus 1. So here the image form is inverted and of same size. Next question. Question number 2. Given object distance is minus 30 cm, focal length minus 15 cm. So what we have to find? We have to find the image distance and the magnification formula to find magnification. First we will use the mirror formula. 1 by f equal to 1 by v plus 1 by u minus 1 by 15 equal to 1 by v minus 1 by 30. 1 by v equal to minus 1 by 15 plus 1 by 30. 1 by v equal to LCM is 30 minus 2 plus 1. Implies that 1 by v equal to minus 1 by 30. Implies that v equal to minus 30. Next is magnification. So here we get after mirror formula V equal to minus 30 cm. Mirror from using magnification formula m equal to hi by ho, but here also image distance and object distance, height of the image and height of the object is not given, so we can put the formula minus v by u, that is minus of minus 30 by minus 30, that is minus of 1 equal to minus of 1. The magnification for this mirror is minus 1. Next, we'll move to the next question. Given image distance is given as minus 40 cm and object distance is given as minus 20 cm. We have to find focal length using mirror formula and again magnification. According to formula, 1 by f equal to 1 by v plus 1 by u, that is 1 by f equal to minus 1 by 40 minus 1 by 20. 1 by f equal to 40 minus 1 plus 2 implies that 1 by f equal to 1 by 40. F equal to 40 cm. So after using mirror formula, we get that focal length of the image is 40 centimeter, for which the object distance is 20 centimeter, minus 20 centimeter, and image distance is minus 40 centimeter. Next, we'll find magnification. Minus v by u, as here also image distance and object height and image height is not given. Minus of minus 40 by minus 20 minus 2. Minus 2 is the magnification. Given, this is the fourth and last question. Given HO is 5 centimeter, U is minus 30 centimeter, V is minus 15 centimeter. V is minus 15 centimeter. Here we have to find HI. So first we'll put mirror formula and find focal length. Then using magnification formula, as magnification there is two formula. First is minus v by u and another one is hi by ho. So here we can conclude that minus v by u equal to hi by ho, and so hence we have to find in this question is hi. So we can find hi through magnification formula. 1 by f equal to 1 by v plus 1 by u equal to minus 1 by 15 minus 1 by 30. 30 minus 2 plus 1 equal to minus 1 by 30. F equal to minus 30. So here we get focal length as minus 30. Next we have to find hi. After using mirror formula, we get focal length is minus 30 cm. According to formula, m equal to minus v by u or hi by ho implies that minus of minus 15 by 30 equal to hi by 5. Minus minus cancel, it's minus 1 by 2 equal to hi by 5. Minus 5 by 2 equal to hi implies that hi equal to minus 2.5 centimeter. So by using magnification formula, that is minus v by u equal to hi by ho, we get the height of the image is minus 2.5 centimeter, And this is all for today. In this class we studied what is reflection, laws of reflection, beams of light, and then magnification formula, mirror formula. In the next and we have also solved some numericals based on it. In the next class we will proceed to refraction, lenses, types of lenses, and etc. So thank you.